Hello students, this is V. Srinivas working in SRR Government Arts and Science Degree College. Today I am going to discuss about the topic is synchronization and hardware in operating system. This topic is taken by 5th semester NPCS final year Unit 4. The subject is the synchronization and hardware in operating system. So what is synchronization? So first of all we discussed the previous class. We are discussed by the execution and the concurrency and race condition and critical section and what are the solutions of critical section problems. So the concurrency is the interleaving the processing time to give the appearance of the simultaneous execution. The operating system allows multiple programs at a time to run at the same time is called concurrency. So the multiple programs are run in the single user and the multi-user operating system. So the different systems and run the different types of programs. In the multiple programs run the one system. So which type of multiple programs? So we are using the different types. The multiple program means we are doing work documentation and program execution and see the web websites, the different types of websites. And next one, this the you listen the songs. So this type of programs run in the multiple operating system. So the simultaneous execution, the appearance concurrency interleaving process is called the concurrency. So race condition is the several process access and the multiplicates the same data information concurrently, and the outcome of the execution depends on the particular order in which the access take place is called race conditions. And we discussed about a critical section. So what is critical section? A critical section is the code and the segment that the access is shared variables and has to be executed the automatic action. So it means the group of operating the process at a given point of time. So only one process must be executing its the critical section. If any other the process also the wants to execute its the condition section and must be utilize the first and one finisher. The solutions to critical section problems, the mutual execution and the process execution and the bounded waiting. So they discuss today we discussed by the topic is synchronization. So what is synchronization? Many systems provide hardware support for the critical section code. So we are getting some problem the time we are using the supported by the many systems provide the hardware support. Without hardware support, the we get the critical section in the some problems. So hardware is the supported to say developed by the critical section. So what is hardware? The system physical component is called hardware. The critical section problem could be solved easily in the single process environment. We could disallow the interrupts to and occurs while shared and the variables or the resource is being and modified. So in this the manner we could and be sure that the current sequence of the interactions would be allowed to execute in the order and without preemption. And unfortunately this solution is not feasible in a multiprocessor environment. So the disabling of the interrupt on the multiprocessor, the environment can be time consuming as the message is passed to all the processors. This message and the transmission lag and the delays entry of the threads into the critical section and the system efficiency dis- diseases. So, and the mutex clocks as a synchronization hardware solution is the not easy to implement for everyone. It is strict software approach called the mutex looks was introduced. In this approach is the entry section of code, the lock is accrued over the critical and resources modified and used inside critical section and in the exit section that a lock is released. So as the resource is locked while a process executes its the critical section, hence no other process can access it. So in this the main the synchronization topics are background and the critical section problem, the Peterson solution, uh, Peterson solutions, and the synchronization hardware, uh, semaphores. Next one, the classic problem of the synchronization monitors, synchronization examples. So automatic transactions. So these subtopics are we discussed in this class. The objectives to introduce the critical section. It is a problem whose the solutions can be used to entire con- consistency of shared data. So what is the shared data? The multiple operating system, it is supported with the thin client systems. So it is the server and the clients, number of clients are there, 1 to 10 clients, so whose the solutions can be used to and ensure the concurrency of shared data. So we have the shared data here to that place. To present both software and hardware. So already we know we discussed by the software definition, and the set of programs is called software, set of instructions is called program, and hardware is the physical component of computers. So these the software and the hardware solutions of the critical section problem. The both are more important to the user. So the system software is used to the system run, the application software used to the users, and hardware software is the different types of installed and used by the personal and the office purpose. To introduce the concept of the atomic transaction to describe the mechanism. So and next one is the background. The concurrent access to shared data may result in data inconsistency. So maintaining data and consistency requires mechanisms to ensure the, the orderly execution of the cooperating processes. Suppose that we wanted to provide a solution to the consumer producer the problem that fills all the buffers. We can do so by the having an integer count that keeps a track of the number of faults and the buffers and the initially counting sent to 0. So it is incremented by a producers after it is the produces a new buffer and is the decremented by the consumer after the consumes a buffer. So this is the background. The consumer access shared data. So one system to another system we transfer the data, that is the data consistency, and the maintaining the data consistency ensures the mechanisms the process. And some problems requirements, the execution, mutual execution and the process and the bounded waiting already we discussed by previous class. Just to see once again, it is a process p1 is the executing in its the critical section, then no other the processes can be and executing in the either critical section. The process, if no process is executing in the critical section and there exists some of the processes that wish to and enter their critical section, then the selection of the processes that will be enter the critical section next cannot be the postponed to and infinitely. Bounded waiting, a bounded waiting exists of the number of times so that the other processes are allowed to enter their article sections after a process has made the request to and enter its critical section and before the request is granted. Assume that each process executes at a the non-zero and the speed uh, non-zero and speed the non no assumption the concerning of the relative speed of and the process. This is the problem. The Peterson solutions. So the Peterson is the author two process solutions. We assume that the load and the store and the instructions are the atomic, that is cannot be interpreted interrupted. The two processes share two variables. They are the int term and the boolean flag 2. The variable term the indicates and whose uh, term it is and to enter the critical section. The flag array is used to indicate if the process is and ready to enter the critical section. Flag 1 true implies the process P1 is ready. The synchronization hardware. So the synchronization is the hardware is the what is the relationship? The many systems provided by the hardware support to critical section code. So the critical section is the very problem uh, uh, created by the every system. So the many systems provide the hardware support. So the critical section code is the supported by the hardware to many systems. The thin clients, this is the server is one and the more than two systems, that is called networking system. So in this networking the server is the most important. Without server the clients are thin clients are not opened because we are creating the password to that server system. So this is the execution without the preemption and generally true and insufficient on the multiprocessors and the systems. The operating system using this not broadly this scalable. So modern machines provide the special atomic the hardware instructions. Here the atomic non-interruptible and the enter the test memory word and set the values or the swap the content of two memory provides word. So this is the synchronization and the hardware. The hardware is a physical component of computers. Many more systems provide the hardware supported by the critical section. So this is called synchronization. So what is a semaphore is? So a semaphore is f is a and the integer type variable. The semaphore is assumed the only through two standard atomic the operations wait and the signal. The wait and the operation was originally and turned behind the signals and was the original called v and the wait operation decreases the values of each the assumes so soon as if the would become non-negative and the greater than or the equal to 1. The signal operation, the increment the values of and its the arguments as there is no more process and blocked on the queue. This is properties of the semaphore is the simple and the always has a non-negative integer value, so works with the many processes. This is the most important is that the work with the supported by the more memory processors can have many different critical sections with the different semaphores, and each critical section has this critical section has the semaphores and can present and permit multiple processes into the official section of once and if desired. So these are the many types are there. The binary semaphores and the counting semaphores. The binary, so binary semaphores is a special from the semaphores used to implement and the natural execution, and hence it is often the called the mutex. A binary semaphore is the instructed to one and only takes the values 0 and 1 during execution of a program. And the next one coming say semaphore is the counting, and the semaphore is used to interest and the bounded concurrency counting. The semaphores can be implemented using easy and the ultimations of the semaphores. So what is ultimations? Deadlocks. The implementation of the semaphores with the waiting queue may result in a situation where two or more the processes or the waiting identifiably for an event that can be the waiting the process. So semaphore is synchronization tool that not and require integer variables to standard operation system. The modifies weight and the signals. The less compiled, the less complicated can only accessed via two uh, indivisible automatic operations. Semaphore is as the general synchronization tool. The counting semaphore is integer value can the range over and unrestricted domain. The binary and the semaphore is integer value can range only between 0 and 1 and can be simple to implement. So also new as the mutex locks and can be implemented the counting semaphores yes, as a binary semaphores provide the mutual execution. The semaphores mutex the initializer to 0 do wait, and the mutex the critical section signal mutex and the reminder section. So this is the condition is the do while program execution the code. So semaphore is implementation. So wait the grantee guaranteed that no two process can execute wait and the signal 0 on same the semaphore is at the same time. Thus the implementation becomes it the critical section, the problem where the weight and the signal code are placed in the critical section could now have busy waiting in the critical section and the implementation. So but the implementation code is short and a little busy waiting if the critical section rarely occupied. So note the applications may spend a lot of time and the critical section and therefore this not a good section. And the limitations of semaphore is the deadlock. The implementation of the semaphore is with a waiting queue may result the solutions solutions queue result in a the situation where two or more process are waiting and identifiably for as event that can be caused only by one of the waiting processes, and the event in the question is the execution of signal operations. When such a state is reached, these processes are said to be and deadlock. The starvation or the indefined blocking is the phenomenon associated with the priority and scheduling algorithm in which a process ready to run for central processing unit can be wait identifiably is called uh, starvation. So the another topic is the critical reason. The concurrent, the programming, the concurrent access to shared and the resources can be lead to the next protected and erroneous behavior. So parts of the program where the shared resource is the access as the protected. This protected section is the critical region. So with each the semaphore is implementation with no busy waiting. So with each semaphore is there is associated with a waiting queue, and each entry waiting queue has two data items. So that is the value of type integer and the pointer to next record in the list, and there are two operations: block place process invoking the operation on the appropriate waiting queue, and wake up remove one the processes is waiting queue and place it in the ready queue. Deadlock raven uh, deadlock starvation. So deadlock two or more the processes are waiting and identifiably for an event that can be caused by the only one of waiting the processes. Let assign q to the semaphores and the initializations. And the synchronization is the bounded buffer problem. The every time the type of three programs are implemented in this one, the bounded buffer problem, reader and writing problem, uh, dining and the philosopher's program. So these are the problems of the synchronization. The bounded buffer program. So no buffers each can hold one item, and the semaphore is mutex and I initialize it to the value 1 and the semaphore is full. I initialize it to the value 0 and the semaphore is empty. Initialize it to the value n. So here readers writers problem. The systems the clients are used by the user, and some of the writers we are executed the programs the time they are get the some different types of problems and updated. So writers can both read and write the problem, allow the multiple readers to read at the same time, and the only one single and the writer can be access the shared data at the same time. Shared data, the data set and the semaphore mutex and the initialize it to 1, the controls access to the read count, and the semaphore is WRT initialize it to 0 1 of writer access, and the integer read count the initializer 0 how many processors and the reading object. So the processors is the main important role in the systems, the execution of the different types of programs. The depending on the speed, the motherboard is the main. In this motherboard main important is the system, the processor available for the different types of the processors process. The in this the multiple processors available in the single systems, that is the just we take the one example, two systems are working the to both users, but the both system the single user can use the both systems in this dual core processor. So that is the main advantage of the central processing unit, the CPU and the central processing unit related to the operating system. So the mutex inside the control access and the read count, semaphores and the write initialization 1, writes access integer, and the read out read conduct read count, and the initialize it to 0 how many processes are the reading object. Here see the dining pillow suffers the problem. So here rise 1 2 3 4 5 1 2 3 4 5 are the dining chairs, and the dining table is there. The centrally it is rice. So share data bowl of rice data set, those semaphores. Here see that this is the best example to the shared data. So the rice is the one, but shared to the five chairs, and five chairs persons also they used by the use they also eat by the rice. So this is the advantage of the user for the shared data. So this time the user can be used the share the food to each and every table person. So this is the share by the rice. So the data is the information shared by the different types of users. So the dining philosophers to problem. And the next one is the more problems with the semaphores and the releases much no programmers and the not making and the mistakes accidentally are the deliberate. So incorrect use of the semaphores, the operations, the signals mutex and the weight mutex and the weight mutex and the weight mutex, the omitting of weight and the mutex or the signal mutex are both. The schematic view of the monitor. Here see the diagram is there. This is the shared data every queue. So queue means the first program completed, the second program will be run, the second program is completed addition, the third program will be run. This is the queue. So first one first out, first which program is come, the program is the completed processing, the second program will be started for the process. So this is shared data. The queue is the one program by one program continuation. The operations and the installation code. And the next monitor with the condition variables. So in this diagram see the shared data in the same queue, each and a one by one program execution. This is the operation installation code, and the queues associated with the xy conditions. so shared data by the different users, so that is the monitor with the condition variables. And the next one, the synchronization examples. What is the examples of synchronization? So these are the multiple operating systems. These are the, just to see the Solaris and the Windows X and the Linux, the threads. So this is the multiple operating systems. So in this, the Solaris synchronization, the implementation a variety of looks lags to support the multitasking, multi-threading, and including the real-time, the threads, and the multi-processing. So this is the Solaris synchronization, and the use adapting and the mutexes for the efficiency when the protecting data from short code segmentations, and uses the condition variables and the readers writers lacks when the longer section of the code need the access of the data. So already we discussed by the data is the information. So the database is the collection of related data, and the database management system is the collection of related organization of different types of data. So in the data is the most important role, the condition variable, and the reads writes the logs when the longer section the code need access. Windows XP synchronizations, the uses interrupt and the masks to protect access to the global resources on the unique processes and the systems. The uses of the spin logs on the multiprocessor systems, as it provides the disruptor objects and which may act to and the entire the mutexes and the semaphores. So the dispatcher objects may also provide events and even acts like the condition of variables. And the Linux synchronization, Linux. So this is also one of the multiple operating systems. The prior to kernel, the version 2.6 and disables the interrupts to implement short critical sections, and versions available for the 2.6 and the latter the full primitive. So Linux provides and semaphores spin locks. See the pre-threads synchronization. See pre-threads API is the OS operating system independent. It provides the mutex locks and the condition variables. Here the non-portable and extension include read write logs and the spin logs. So this is the threads and the p-threads synchronization, and the automatic transactions. In this available for these four topics, and the system model and the log based recovery and the checkpoints and the concurrent atomic transactions. So these are the atomic transactions. System model. So what is the system model? The system model is assumes that the operations happen to single logic unit of the work in it is the enter entirely or not at all. So related to field of the database systems, the the challenge is assuring and automatic despite the computer system failures. So the transactions collection of instructions are the operations the, that performs the single logical function. So here we are the concerned with the changes to the stable storage disk. The transaction is series of the read and write operations. The terminated the commit and the transaction successfully or about the transaction failed operation. The aborted the transaction must be rolled and back to undo any changes it's performed. Next one, types of storage media. The volatile storage, the information stored here and that does not survive system crashes. Example, main memory cache. So what is the main memory? The system operating system store. It is some of the memories that is called main memory, and this is also primary memory. The second storage is the DEF drives are there. We are purchasing the system, so the hard disk is the 1000 GB, and the partitions of the 200 GB, 200 GB, 200 GB, and 200 GB. So that is it was the memory is the secondary storage divided by the user, the hardware, because the C drive is totally stored by the operating system. So just we are not the folders cannot use the C folders because the operating system is there. So non-volatile storage information usually and survives the crashes. Example, disk and tabs. And the goal is to assure the transactions atomic where the failures and the cost loss of the information on the volatile storage on the leg based recovery. So the record to stayable and the storage uh, information about all modifications by transactions. Most common is write ahead the logging and long on the stable storage. Each log and the record describes single transactions. Write the operation including here. See the transaction name and the data item name and the old value and the new value. So T1 starts write to and the log when the transaction T1 starts. The T1 commits and write when T commits. So the log entry must be and reach stable storage before the operation on data occurs. And the log based the recovery algorithms, using of the log the system can handle any volatile and the memory errors. So under redo the restores the value of all data updated by T1 and redo T1 the sets of values all data is information T1 to new and the values. Undo and read must be and identified. So undo T1 and read T1 must be determined. And the next is checkpoints. So what is the checkpoints? Log could be become a long and the recovery could be take long, and the checkpoints is shorten and the log and recovery time. Checkpoint scheme, the output all the log records and currently is the volatile storage to include the storage, and the output all modified the data from volatile to and stable. The storage, the output is the log recover and the checkpoint id, the log, the log on stable storage. So now the recovery only includes T1 and such that Ti started with and execution before the most recent checkpoint and all transactions Ti all other and transactions ready to stable storage. And the next one, concurrent transactions. So what is the concurrent transactions? They must be environment to serial execution and serializability and could perform all transactions in the critical section and efficient to retrieve. Concurrently control algorithms provide serializability and serializability consider to data item A and B and consider transaction 0 and T1 execution 0 and T1 automatically and the execution sequence called as the schedule, automatic execution transaction, other called series scheme. Here some diagram is there, schedule T1 and the one T0 and then T1. So T1 are running process and read, write, read, write. So this is the upcoming running problems. The conserial scheme. Conserial scheme allows the overlap to execute the in the resulting of the execution not necessarily incorrect, and the consider schemes yes operation 0 and the 0 1 completion to access the data item with a last least one right. If 0 0 consecutive and the transmission of different transactions in 0 and 0 don't. So most important, locking protection. Ensure the serial by associating and the log of with each data from. They follow the locking and the protection for the access memory. So this is topic we are discussing by today. These the semaphores and implementation of schemas. So and monitors. These topics are discussed by yesterday and today also repeated by once again. So this is of the synchronization there are hardware and he went to the mutex orders already booked, so you get profit or loss. So mostly it is the process is the system provide hardware support the critical section. So these are the main important topics of the hardware and the synchronization relation. Thank you students.